In this video, I want to talk about querying and searching KDB.AI. KDB.AI supports a lot of really advanced filters, and I think the best way to really understand them is to just look at some code. So let's get started. Now, I've already installed KDB.AI client, so let me import some dependencies. And I already have my environmental variable set, so I could just connect to my session. And let's also connect to the default database in KDB.AI. Now, when you start, you have the options to just connect to the default database, or you could create your own databases if you'd like. Now, our schema is going to look a little bit like this. We have an ID, which is just going to be an integer. We have a name, we have an age, a city, and some embeddings, which is just a bunch of floats, of course. And then we have our index. Now, we only have one index. This is our vector index, and it's going to be of type HNSW. And it's going to have vectors of 120 dimensions. So now let's create this table with a schema and indexes. So we're going to create a queryable table, or a table called queryable. Next, I'm going to create some dummy data. So our dummy data is going to have some vectors, and these embeddings are just going to look like, numbers repeated, 111 repeated, 222 repeated, and so on. And let's just make sure I have that. And next, I'm going to insert that data into my table. So I've inserted 5 rows. And finally, let's query our table to make sure we have everything in there. And we do. So our embeddings look like this. And we have 5 people: Alice, Bob, Charlie, Monica, and Nate. Now, our next step is to look at this query function. Now, our query is just going to query everything. But now we're going to add a filter, right? We're going to add a filter. And we're going to limit this to people in London and Tokyo. So we have a filter of age must be greater than 30, and these people have to be in London or Tokyo. And we can also do an aggregation where we only take certain columns. So here we're taking the name column and we're taking the city column. And now we reduce the amount of information passed from the server, from our database to the server by only taking certain columns. Next, let's create a more advanced aggregation where we're creating a new column called max age, where we're taking the max of the age. Now, to look at all these possible aggregations, we could look at the documentation. Here we have max, min, and all these different aggregations. A lot of these we're going to look at in this notebook. So let's actually query this, and we're going to also group by city, and we're going to sort by max age. And this is what happens. We're sorted by max age, and we're grouping by city. So the max age in New York is 25. Next, let's try some other aggregations. So we can get the average age, and then we can count the number of names, which means the number of individual people. So now let's make a query with these aggregations. And let's group by city and name. And what do we get as a result? What we get is we're getting this city column, this name column, the average age for, these two columns for every row, and also the number of individual people. Now, since one of the columns is name, every person is going to have their own name. So, of course, the count name is going to be 1. Now, let's try something else. We're going to have the aggregations of average age and the number of people in each city. But here we're only grouping by city. So our result should be that we get all the number of people in each individual city. And so we get 2 people in London and 1 in every other city, just as expected. Now we could customize these filters further. For example, we could filter by age being less than 30, but we could also filter with an operator like. So here we're fetching people with a name that starts with this pattern A star. And this pattern A star means anyone whose name starts with the letter A. So we could choose any pattern. And there's only one person, I believe, whose name starts with the letter A, and that's Alice. So we fetch her. And luckily she's under 30. Next, we could try some filters like people older than 30 and in London or Tokyo. So we could use this in filter here. And here are the people that we get: Bob, Charlie, and Monica. All right, so these are the queries, but let's try some searches. And for this, first I'm going to add some more people. So I've added 20 more people. And let's look at these people. So these people have vectors that, starting at 0.6, just increase by around 0.4, starting at 0.64. Or 0.2. Starting at 0.6, they start increasing by 0.2. And we have 20 more people. Now let's make a search. Now, when we make a dense search in KDB.AI, here we have a vector index, which is dense vectors. We pass a vector. So here, we pass a vector of 0.1 repeating. So what that means is, in multidimensional space, there's a bunch of people that's around 0.1 repeating, and we're going to take the closest ones. Now, since this is an HNSW index, this isn't going to be an exact search. But since our table is so small, it's going to function basically like an exact search. So here we have 3 people, and we see that their vectors are very close to 0.11. If we go back here, these are the closest people to 0.11 in multidimensional space. All right. Now for large workloads, you can make multiple searches at the same time. Here we're searching 0.1 repeating and 0.6 repeating, and we're getting 3 results. So let's see the result here. So here we have the same result as the previous search, and then we have a lot of people that surround 0.6 repeating. In addition to regular queries, just like regular queries, I could add aggregations. So here I'm searching with 0.1 repeating vector, but I'm adding the aggregation of only taking the name column and the city column. That's exactly what I get. I get the name column and the city column. I could do more complex aggregations with my search. Here I'm adding the column of max age, and I'm grouping by city, and I'm sorting by max age. So this is basically making a search, doing this aggregation, grouping by city, and then sorting by max age. And this is the result. Now, we could also do a filter on our search. Filters are interesting because when we do a filter, we're actually doing the filter first. So here in practice, when we search this vector of 0.4 repeating, what's going to happen is first we apply the filter of people who are younger than 30 years old. And then we make a search with this vector. And if we have millions or tens of millions of rows or vectors, then this is going to massively speed up our searches in practice. So let's try this. And here we should filter by people younger than 30. And looks like there's only one person that satisfies this requirement. Even though we have n set to 10, we're only getting one result because only one person satisfies this requirement. And that's because when this filter was implemented, there was only one result for us to really search. And finally, since we're done, let's drop this table. I hope this was helpful, and I can't wait to see you in the next video.